Hello students and welcome to you with another interesting problem based on the concept of increasing and decreasing function, and this is an application of derivative problem based on application of derivative of your standard 12 mathematics, okay, from your Ncert book. Is it clear? And here in this question I am going to explain. We have to find out the intervals in which a function f is defined by fx is equal to sin x plus cos x, increasing or decreasing in the interval 0 is less than equal to x is less than equal to 2 pi. Okay, understood? Here is function is given that fx is equal to sin x plus cos x. We have to find the intervals in which the function fx increasing or decreasing. Understand the question? The interval is given 0 is less than equal to x is less than 2 pi. Okay. So let's see the function fx is equal to sin x plus cos x. Let us find out the derivative f dash x, first order derivative x fx f dash x. Okay. And derivative of sin x is cos x. And derivative of cos x, what is the derivative of cos x? Is minus sin x. Understand or not? Let us equate cos x minus sin x. You see, cos x minus sin x. The cos x minus sin x you can write also. Let us simplify this one. Root 2 whole into 1 by root 2 cos x minus 1 by root 2 sin x. Here you multiply root 2 by root 2, and where root 2 keeping before the bracket, here 1 by root 2 is multiplied with cos x and 1 by root 2 is multiplied with sin x. So root 2 whole into 1 by root 2 cos x minus 1 by root 2 sin x. Let us take common minus root 2. Minus root 2, if you minus root 2, it will be 1 by root 2 sin x minus 1 by root 2 cos x. 1 by root 2 cos x here. So minus, if I bring the minus sign here, this minus 1 by root 2 sin x will be plus 1 by root 2 sin x, and this plus 1 by root 2 cos x will be minus 1 by root 2 cos x. Okay. So minus root 2, you can write 1 by root 2. How can you write? Cos pi upon 4. We know cos pi upon 4 is equal to root 2, and also sin pi upon 4. Pi by 4 is also root 2. 1 by root 2, not root 2, 1 by root 2. 1 by root 2. Yes or no? Understand? So in place of 1 by root 2, I can write cos pi by 4 into sin x minus 1 by root 2, here we can write sin pi by 4 into cos x. Is it clear, this point? Understand? So that implies minus root 2. You see sin A into cos B minus cos A into sin B. You know a formula in class 11. Sin A into cos B minus cos A into sin B. What is the formula? And that is the formula sin A minus B. Is it clear? Okay. So here you see sin x minus pi upon 4 a minus b. Here sin a into cos b minus cos a into sin b, and here the formula is minus root 2 sin x minus pi by 4. Here f dash x we got. So we got f dash x is equal to, okay, let's write down the f dash x we got. F dash x we got minus root 2 sin x minus pi by 4. Is it clear up to this? Okay. First you found the derivative of the function. Okay. Understand? Okay. Now you see, let us equate after finding the derivative. Understand? After finding the derivative, we have to equate. You see now, f dash x 0. Let us f dash x is equal to 0. Equate. Here, it means, if you see, it will be sin x minus pi by 4 is equal to 0. Yes or no? Because minus root 2 will be transposed It will be sin x minus pi by 4 is equal to 0. And now 0 means what? All of you know, sin 0, or you know sin pi also know. We know sin 0 is equal to 0 and sin pi is equal to 0. Yes or no? So that implies x minus pi by 4 is equal to 0 and we can write pi. Yes or no? That implies x is equal to pi. It means x minus pi by 4 is equal to 0. X minus, write down x minus pi by 4 is equal to 0. And x minus pi by 4 is equal to pi. Yes or no? So here x is equal to pi upon 4. X is equal to pi upon 4. Pi by 4. And x is equal to here pi plus pi by 4, which is 5 pi by 4. So we got the point x is equal to pi by 4 and x is equal to pi by 4. Thus we got x is equal to pi upon pi by 4 and 5 pi by 4. And the domain x is equal to pi by 4 and x is equal to 5 pi by 4 divides the interval 0 to 2 pi, close interval 0 to 2 pi into the 3 disjoint interval. Let us see. We got the domain x is equal to pi upon 4. Another is 5 pi upon 4. So this x is equal to pi by 4 and 5 pi by 4 divides the real number lines domain. This is what? Here you see pi upon 4. It is what? 5 pi upon 4. And it is 2 pi. And this value is 0. So x is equal to pi by 4 and x is equal to 5 pi by 4. Divide the real number line into 3 disjoint interval. One interval is what? One interval is 0 pi by 4. Another interval is what? Pi by 4 into 5 pi by 4. And third interval is 5 pi by 4 and 2 pi. Thus we got 3 intervals. Okay. Understand? And in this interval we have to see whether the function, in which interval the function is increasing or decreasing. Understand or not? It's okay? It's okay? Let us write. Let's write. So, what we got here, here we write down. Hence, the point, the domain x is equal to pi upon 4 and x is equal to 5 pi upon 4 divides the real number line into 3 disjoint intervals. Which intervals? One interval is what? 0 to pi by 4. And second interval is pi by 4 to 5 pi by 4. And third interval is that 5 pi by 4 2 pi. 5 pi by 4 to 2 pi. Okay. Understand? Is it clear? Okay. Let's see. In these intervals, let's see in which interval the function is increasing or decreasing. Okay. Let's note down. Let's proceed. Okay. So we got here f dash x minus root 2 sin x minus pi by 4. Okay. And in the first interval, let us see. In the first interval, what is the first interval? 0 to pi upon 4. Okay. And 0 to pi upon 4. That implies that x belongs to 0 to pi upon 4. That implies 0 is less than x is less than pi upon 4. Its x value lies between 0 to pi by 4. Understand or not? That implies, so 0 here function is, what is the angle? Here angle is what? Sine x minus pi by 4. So let us see, 0 minus pi by 4 subtract is less than x minus pi by 4 subtract is less than pi by 4 minus pi by 4. Understand or not? So that implies minus pi by 4 is less than x minus pi by 4. Okay, is less than 0. Is less than 0. Is it clear? That implies, you see now, x minus pi by 4 0. X minus pi by 4 and 0. It means x minus pi by 4 you write down. That implies, you see, sine minus pi by 4 is less than sine x minus pi by 4 and is less than sine 0. Less than sine 0. That implies minus 1 upon root 2 is less than sine x minus pi by 4 is less than what? 0. Sine 0 is 0. It means you are saying that implies the sine x minus pi by 4 is less than 0. You are getting here. Sine x minus pi by 4 less than 0. Okay. That implies you will multiply minus root 2 sine x minus pi by 4 must be greater than 0. Yes or no? If sine x minus pi by 4 is less than 0, so minus root 2 sine x minus pi by 4 is greater than 0. That implies f dash x is greater than 0. And we know if the f dash x is greater than 0, derivative of the function is greater than 0, then the function is increasing function in the interval 0 to pi by 4. Understand? Yes. Thus, the function, right, since you see f dash x is greater than 0, thus the function f is increasing in the interval 0 to pi upon 4. Is it clear? So in this function, you see 0 to pi by 4, this function is increasing. This function is increasing. This function is increasing. This value function is increasing. Similarly, let's see in the interval pi by 4 to 5 pi by 4. Is it clear? Understand? Whether the function is increasing or decreasing function. Let us come to the second interval. Okay? Note down here. Let's see. So one point you got, in the interval 0 to pi by 4, the function is increasing. Okay, is it clear? Now let us come to the second interval. What is the second interval? Another interval is that, what? This is what? Pi by 4 to 5 pi by 4. Pi by 4 to 5 pi by 4. It means here x lies between, here x belongs to pi by 4 and 5 pi by 4. Okay, it means domain of the function lies between pi by 4 to 5 pi by 4. It means pi upon 4 is less than x is less than 5 pi upon 4, 5 by 4. Understand? Now pi by 4 minus pi by 4 is less than x minus pi by 4 is less than 5 pi by 4 minus pi by 4. Is it clear? That implies 0 is less than x minus pi by 4 is less than pi. Is less than pi. Understand or not? It means the domain of the function lies between 0 to pi by 0 to pi. 0 to pi means which quadrant? Let us see. 0 to pi means which quadrant? 0 and pi in first quadrant and second quadrant. Understand? That implies x minus pi by 4 belongs to lies in first quadrant and second quadrant. And in the first quadrant, second quadrant, you know, sign okay, function is positive. The sign is positive in the first and second quadrant. All of you know. That implies the sign x minus pi by 4 is greater than 0. Why? Because the sign is positive. Sign is positive in first quadrant Q1 and second quadrant Q2. Second quadrant Q2. The sign is positive in the first quadrant Q1 and second quadrant Q2. Understand? So since sin x minus pi by 4 is greater than 0, here the f dash x is minus root 2 sin x minus pi by 4. Let us multiply minus root 2. If you multiply minus root 2, it will be minus root 2 x minus pi by 4 will be greater than will be what? Less than. Yes or no? That implies f dash x is less than 0. And we know if the first order derivative is less than 0, then the function is decreasing function. Yes or no? In the interval what? In the interval pi by 4 to 5 pi by 4 thus. Hence, the f is decreasing function. Decreasing function. Yes or no? In the interval pi by 4 to 5 pi by 4. In the second interval, if the function is decreasing function in the second interval. Yes or no? Yes. Is it clear? The function is decreasing in the second interval. Second interval, the function is decreasing. Okay. Now let's see in the third interval. In third interval is what? 5 pi by 4 and 2 pi. Let us check whether the function is increasing or decreasing. Let's see. Is it clear? Understood? Okay. Let's move to another concept here. So the function is what? Decreasing in the interval pi by 4 to 5 pi by 4. Now let's see in the third quad. In the third interval. So third interval. What is third interval? Yes. Third interval is that x belongs to what? 5 pi by 4 to 2 pi. Yes or no? Yes or no? That implies 5 pi by 4 is less than x is less than 2 pi. Understand? That implies 5 pi by 4 minus pi by 4. Because x lies between 5 pi by 4 and 2 pi. Then x minus pi, your angle is what? X minus pi by 4. If x minus pi by 4 lies in which interval? If x lies in the interval 5 pi by 4 and 2 pi, you have to find out. Here the angle is x minus pi by 4. We have to check in which interval does it lie. So 5 pi by 4 minus pi by 4 less than x minus pi by 4 is less than 2 pi minus pi by 4. Is it clear? And that is equal to what? Pi less than x minus pi by 4, okay, is less than what? 2 pi minus pi by 4. You see, 2 pi minus pi by 4, this is lies in the which quadrant? Which quadrant? So this x minus pi by 4 lies between, okay, look at here. Look at here. Look at here. And this is what? Pi. It means the x minus pi by 4 lies between pi to 2 pi. This angle is 2 pi and pi by 4 means which quadrant? Which quadrant? Third quadrant and fourth quadrant. Angle lies in the third quadrant and fourth quadrant. Third quadrant and fourth quadrant. And you know in the third quadrant and fourth quadrant, sign is negative or positive? Yes? According to ASTC rule or sugar to coffee. Okay. In the third quadrant and fourth quadrant, you know the sign is negative. So that implies You see, the x minus pi by 4 belongs to pi. 2 pi minus 4 is equal to, we can write 8 pi minus, this is 7 pi by 4 also we can write. Understand? 7 pi by 4. If you simplify 7 pi by 4. Understand? So x minus pi by 4 belongs to pi minus pi 7 pi by 4, which is lies in third quadrant and fourth quadrant. Yes or no? So we know that in the third and fourth quadrant, okay, the sign is negative. Sign is negative. That implies the sign x minus pi by 4 is less than 0. Negative means less than 0. That implies minus sign minus, what is the function f dash x? Minus root 2. Multiply minus root 2. So minus root 2 is sin x minus pi upon 4 is less than 0, and that implies f dash x is less than 0. Clearly, since f dash x is less than 0, we know that according to the definition of the increasing and decreasing function, okay, using the concept of the derivative, if f dash x is less than 0, then the function lies in the which quadrant? Function is negative or positive? Function is negative. Thus, f is negative. Hence, f is negative. F dash is less than 0. So, it will be what? The function is said to be decreasing function. Decreasing. The function is decreasing in the interval. In the interval what? In the interval 5 pi by 4 and 2 pi. Understand? So, the function is one mistake, sorry, if sin x minus pi by 4 less than 0, here minus root 2 sin x minus pi by 4, one mistake is there, students, okay, just to rectify here, and this inequation will change, okay, sorry for that, minus root 2 sin x minus pi by 4 greater than 0, and here f dash x is greater than 0, okay, so f dash is greater than 0 means what? The function is increasing function, not decreasing function, extremely sorry for that, so it is increasing function. Increasing function. So the function is increasing in the interval, in the third interval, okay, the function is increasing, understand? So see, in the interval 0 to pi by 4, the function is increasing. Is it clear once again? And in the interval 5 pi by 4, 2 pi, the function is also increasing, understand? And in the interval pi by 4 and 5 pi by 4, the function is decreasing function. Let us write conclusion, our conclusion. Okay, what we got? What we got here? We got here that, you see now, this is pi upon 4, and this is 5 pi upon 4, and this is 2 pi, and this is 0. So in the first interval 0 to pi by 4, the function is increasing. Okay, in the second interval the function is decreasing. In the third interval function is increasing. Thus, okay, thus you get that. What you got? The f is increasing function. F is increasing in the interval 0 pi by 4 union second interval 5 pi by 4 and 2 pi. Again the function is f is decreasing in the interval what? Pi by upon 4 and 5 pi upon 4. Understand? This is the required answer, and which we are going to find out. Is it clear, students? So I hope you will understand it. Okay, understand, and also follow it and practice it. Okay, and this is most of the important questions for you, not only for your every competitive exam also you will find in future. Okay, let's practice, let's see. Okay, once again, thank you for your interest. Thank you once again. See you, all of you. Bye. Okay, students, in this class I am going to discuss another simple questions. based on the concept of increasing and decreasing function from your Ncert book, class 12. Okay, application of derivative. Understand? This is one of the important application of derivative, increasing and decreasing function. Here we are discussing the problem. Here the question number 2 I am discussing, and in this question it is given that so that the function f is given by fx is equal to e to the power 2x is strictly increasing on the set of real number r. Okay, let's see. Here the function given y is equal to fx. Here given that fx is equal to e to the power 2x. So you have to find out the derivative of the function, which is f dash x is equal to 2 into e to the power 2x. Okay, understand? Is it clear? Now let's see different case we have to see. Case 1, when you have to see the function is increasing, strictly increasing in every point in the domain of the function. So let us see that when x is greater than 0, when x is greater than 0, understand? Okay, we have to check the case 1, 3 cases where the function is increasing and x is greater than 0, then x is equal to 0 and x is less than 0. Understand? Suppose you take the here x is equal to 0, then in this function this is minus infinitive and this is plus infinitive, and x is also equal to 0. Understand? In every point the function should be strictly increasing. Function should be increasing in every point of the domain of the function. Then the function will be a strictly increasing function. Let's see. So first of all, see when x is greater than 0. X is greater than 0 means which interval? That implies x belongs to which value? 0 to infinity. In this interval. Understand? So when x is greater than 0, you see now f dash x is equal to 2 into e whole to the power 2x. Understand or not? If x is positive, and all of you know that 2 into, what is the value of e to the power x? 1 plus 2x. If you will expand this one, and it is 2x whole square by 2 factorial plus 2x whole to the power 3 by 3 factorial. All of you know. You will expand e to the power 2x. It will be 1 plus 2x divided by 1 factorial. 1 factorial means what? 1 factorial, which is 1. 2x whole square by 2 factorial, and this value are positive value. Understand or not? 2 value, this value are positive. That implies means greater than 0. So that implies f dash x is greater than 0. That implies f is in the interval when x is greater than 0. Understood? Thus f is increasing function. Thus f is increasing function in the interval what? 0 to infinity. 0 to infinity. Is it clear? So we got f is increasing function. F is increasing function. So case 1 we got. From the case 1 we got f is increasing when x is greater than 0 or in the interval 0 to infinity. Is it clear? Understand? Then another point we have to check case 2. Case 2 when x is equal to 0. Case 2, let's see. Case 2. Okay. Let us write down. Is it clear? This is the, we saw here x is equal to 0. Here less than 0 and is greater than 0. We got. Here x is greater than 0, here x is less than 0, and x is equal to 0. In 3 cases we have to see. So case 1 we already got. In the case 1, f is increasing when x is greater than 0 and in the interval 0 to infinity, right? Similarly, case 2 when x is equal to 0. When x is equal to 0, then f dash x derivative function is 2 into e to the power 0, and that is the what? 2, and we know 2 is greater than 0. And since the derivative of function, the slope of the function is greater than 0, that implies f is increasing when x is equal to 0, case 2. Is it clear? So we got case 2, f is increasing when x is equal to 0 or at x is equal to 0, right? Understand? Let another case is case 3. In this case, we have to see x is less than 0. It means this interval we saw. Here the function is increasing, this function area increasing, art also increasing. Now 0 to infinity, when x is less than 0, that is x belongs to which interval? Minus infinity to 0. In this interval, if you see, is it clear? Let x is equal to suppose minus k. Let x is equal to minus k, negative value. Then what is f dash x? Okay, is equal to 2 into e to the power 2x means minus 2k, and that is equal to 2 divided by e to the power 2k. And you see this 2 e to the power 2k is positive, so that's also equal to, that also greater than 0, right? That implies f dash x is also greater than 0, hence f is increasing when x is less than 0. It means interval minus infinity to 0 in this interval. Thus we got in the third interval also, you see, in the interval this also increasing function, Case 3 we got f is increasing in the interval when x is less than 0. It means interval minus infinity to 0. Is it clear? So we got in case 1, f is increasing when x is greater than 0 or in the interval 0 to infinity. Again the function is increasing also when x is equal to 0, and according to case 3, f is increasing when x is less than 0 or in the interval minus infinity to 0. Since the function is increasing in every point in the domain of the function, so the function is strictly increasing. The function is said to be strictly increasing. Yes or no? Understand? Is it clear? Since the function is increasing, f is increasing in when x is greater than 0 or interval 0 to infinity, and f is increasing at x is equal to 0, yes or no? And f is increasing when x is less than 0 or minus infinity 0. Thus it is clear that f is hence f is strictly increasing okay on the set of real number R. Is it clear? And this is what the required expression we want. Okay, and whether the function is increasing or strictly increasing in the on the set of real number. Okay, the function is y is equal to fx is equal to e to the power 2x. Okay, just see, let's practice. Thank you, see you. Okay dear students, here I am discussing question number 3 of your Ncert book, standard 12 math. Okay, on the concept of increasing decreasing function, an important concept of application of derivative. And in this question I am discussing question number 3 of exercise 6.2, question number 3. And in this question we have to what is the question given? Let's see. So that the function given by fx is equal to sin x is strictly increasing in the interval 0 to pi by 2. We have to prove. So that the function given by fx is equal to sin x is, number 1 we have to prove, is strictly increasing. The function is strictly increasing in the interval, in the open interval 0 to pi by 2. Again, second point you have to prove that the function f is strictly decreasing in the interval pi by 2 to pi, in the open interval pi by 2 to pi. Understand, in the point C we have to show that the function f is neither increasing nor decreasing in the interval 0 to pi. Let's see now. Let us draw the interval. Here you see, and this is 0, understand, and 0 to pi by 2, understand or not, and this is pi, this is pi. So you see in 0 to pi by 2 the function is strictly increasing, and in pi by 2 to pi the function is strictly decreasing. We have to prove that. Okay, let's see. Now student, the function is given fx is equal to fx given sin x, understand or not? So that implies find the derivative of fx. For increasing and decreasing function we have to find the derivative of the given function. So the given function is fx is sin x, so f dash x is equal to cos x, derivative of sin x is cos x, understand or not? Okay, and number A, in the interval when x belongs to 0 to pi by 2, 0 to pi by 2, we know that. What do you know? 0 to pi by 2. Here the domain of the function lies in the first quadrant. In the first quadrant, you know the, okay, cos x is positive. So cos x is greater than 0 in the first quadrant. Understand? That implies f dash x is greater than 0. Hence f is strictly increasing, okay, in the interval, in open interval 0 to pi upon 2. Right? Understand? Let us come to the second point. Let us come to the second point. And the second point is that here fx is equal to, you have to find out second point. You have to see, we have to prove that what? The function is strictly decreasing in the interval pi by 2 to pi when the domain of the function lies in the interval, open interval pi by 2 to pi. It means which quadrant? Pi by 2 pi, which quadrant? Here see 0 to pi by 2, first quadrant, and pi by 2 pi, which quadrant? Second quadrant. And in second quadrant, belongs to second quadrant, this value belongs to second quadrant. In second quadrant, you know the cos x is less than 0, negative, yes or no? Yes or no? So that implies f dash x is less than 0. Hence f is strictly what? Strictly, yes, in strictly decreasing. Decreasing, na? Yes, decreasing. Because you know if the derivative function less than 0, then the f is strictly decreasing in the interval, yes, in the interval pi, in the interval, the second interval pi by 2 pi. Understand? Is it clear? Okay. So in the third cases we have to write that. See, in the function we see that the function is increasing in the interval 0 to pi by 2. and the function is strictly decreasing in the interval. This function is strictly increasing in the interval 0 to pi by 2, and the function is strictly decreasing in the interval pi by 2 to pi. So the function is neither increasing nor decreasing in the interval 0 to pi, because the function 0 to pi, here you see the interval 0 to pi means what? The combination of what? 0 to pi upon 2 union pi by 2 to pi. So in the first interval 0 to pi by 2 we saw the function is strictly increasing. In the second interval we saw pi by 2 to pi, the function is strictly decreasing. Yes or no? As a result, the function is neither increasing nor decreasing in the interval 0 to pi by 2. Understand? Thus we can write, hence f is neither increasing nor what? Decreasing in the interval 0 to pi. In the interval 0 to pi. Okay? Understand? Is it clear, all of you? Okay, thank you. See you for the another class here. Okay, till then, bye. So, dear students, in this class I am discussing question number 4 of your Ncert book, exercise 6.2, standard 12 mathematics. Okay, on the concept of increasing and decreasing function, an important concept of application of derivative. Is it clear? So we are discussing the problem based on the Ncert problem based on the concept of increasing and decreasing function. Okay, and important application of the derivative. Using the application of derivative, how can you know a function can be increasing or decreasing? Okay, and here is a question number 4 I am discussing. It is a polynomial function given that, and in this function given that, find the interval. What is the question? Let's see. Find the intervals in which the function f is given by fx is equal to 2x square minus 3x. Fx is equal to 2x square minus 3x is number A. First point we have to prove strictly increasing. Point B, strictly decreasing. Understand? Once again, find the intervals in which the function f given by fx is equal to 2x square minus 3x is bit A strictly increasing, bit B strictly decreasing. We have to find the intervals in which interval the function is strictly increasing and in which interval the function is strictly decreasing. Let's see. So we know that the given function is that the function fx is given, fx is equal to 2x square minus 3x. Okay, so to find the function whether increasing or decreasing, first of all you have to find out their derivative f dash x. So derivative of fx is f dash x, which is 4x minus 3. Understand? Let us equate the derivative of the function f dash x to 0. Understand or not? So that implies, you see, 4x minus 3 is equal to 0. Understand? So that implies x is equal to 3 by 4. It means here, look at here the domain x, okay, the x is equal to, here the domain x is equal to 3 by 4 divides the real number line, divides. Let us see, here is a number line, here the point x, which is 3 upon 4, and this is into 2 disjoint set, into 2 disjoint interval. One is 3 by 4 infinitive, another is minus infinitive 3 by 4. So the domain x is equal to 3 by 4 divide the real number line, because the domain of the function is a real number line into two disjoint what? Intervals. One intervals is what? Minus infinitive 3 upon 4, and another interval is 3 upon 4 infinitive. Understand? Open interval. So let's see, we are getting the two interval. In this two interval, let's verify, let's check in which interval the function is increasing, strictly increasing, in which interval the function is strictly decreasing. Now say in the interval case 1, in the interval when x belongs to minus infinitive and 3 by 4, that implies minus infinitive is less than x is less than 3 by 4. So it means which part? This part. Okay, let us take one point. Let x is equal to, suppose I will take 3 by 8. Understand? So now let us be putting the values x is equal to 3 by 8 in the derivative of the function is equal to 4 into 3 by 8 minus 3, and this is what? 3 by 2 minus 3, and you will get 3 minus 3 to the 6, which is minus 3 upon 2, which is less than 0. That implies f dash x is less than 0. Hence, function, if you will find at a particular point in any of the point, okay, the derivative of function is less than 0. Understand? So the function is what? Strictly decreasing. Is it clear? The function is strictly decreasing in the interval minus infinitive and 3 by 4. In the open interval minus infinitive 3 by 4. Is it clear? So in this interval you will see the function is strictly decreasing. Decreasing, na? Yes, decreasing. Is it clear? Now let's see another interval x 3 by 4 and infinitive. This interval is what? 3 by 4 and infinitive. Here what? Minus infinitive and 3 by 4. Okay, first interval, this is the interval 1 and this interval 2. Let's see. In the second interval, 3 by 4 to infinitive. Let's see. Okay. Okay, let's see in the second interval. Okay, so when case 2, when x belongs to what? 3 by 4 infinitive. Understand? It means we can take any value greater than 3 by 4. Let's value x is equal to, suppose I can take 2 also. If x is equal to 2, then what is f dash x? What is f dash x? The f dash is what? We know 4x minus 3. You see fx. Fx is equal to 2x square minus 3x. Yes or no? Understand? Here f dash x is equal to 4x minus 3. Let us put the values of x. We have taken x value 2, 4 2 ja, 8 minus 3 is 5, which is greater than 0. That implies f dash x is greater than 0. Hence, the function f is strictly increasing. Strictly increasing. Understand? In the interval what? F is strictly increasing in the interval 3 by 4 to infinitive. Is it clear? Thus, point A we got, first point we got in the first point, f is What is the first point? F is strictly increasing. Okay, in the interval minus infinitive to 3 upon 4. Understand? And point B, we got F is strictly decreasing in the interval so is it clear? Very simple question for you, where you can find out the function, you can find out the intervals where okay the function can be strictly increasing, can be strictly decreasing with the help of finding the derivative of the function. Okay, understood? Thank you. Okay dear students, in this class I am discussing question number 5 okay of your Ncert book standard 12 math exercise 6.2 question number 5 based on the concept of increasing and decreasing function and important application of the derivative. Here I am discussing the problem from your Ncert book question number 5, and in this question okay you have to find out the intervals, find the intervals in which the function f is given by fx is equal to 2x cube minus 3x square minus 30x minus 36x plus 7 is point A strictly increasing, point B strictly decreasing. Understand? Here the function fx is given 2x cube minus 3x square minus 36x plus 7. We have to find out the intervals. We have to find the intervals in which intervals the function is strictly increasing, in which interval the function is strictly decreasing. Let's see. Okay, here is another simple problem based on the concept of increasing decreasing function. Here what is function given, students? Fx is equal to 2x cube minus 3x square okay minus 36x plus 7. Is it clear? Now you have to find out, in order to find the increasing decreasing function, you have to find out the derivative. Okay, so what is the derivative of the function fx is f dash x. So it will be 6x square minus 6x minus 36. Okay, that is equal to, bring the common 6x square minus x minus 6. Is it clear? And 6 whole into x square, and it is minus 3x plus 2x. You will factorize it, it is minus 6, and here 6 x whole into x minus 3 plus 2 whole into x minus 3. Understand? So 6 whole into x minus 3 and x plus 2. We got f dash x. Understand? So we got f dash x, derivative of the function fx, f dash x we got 6 whole into x minus 3 whole into x plus 2. Is it clear? Okay, understand? Now let's see, to find the increasing decreasing function, let us equate the derivative of the function f dash x to 0. Then after equating we'll got, what will get? X is equal to, you say x minus 3 whole into x plus 2 is equal to 0, and after that we'll get x is equal to, and the value of x will be x is equal to 3 and minus 2, x will 3 and minus 2. Okay, it means x is equal to 3 and x is equal to minus 2. Let us draw a number line, a real number line. Here x is equal to 3, then x is equal to minus 2. Understand? X is equal to 3 and x is equal to minus 2. Okay, real number line you draw, and here x is equal to minus 2 and x is equal to 3. x is equal to minus 2, x is equal to 3. Here we get plus infinitive, here is minus infinitive, so we are getting the interval. How many interval? 3 interval, 3 disjoint interval we are getting, and so we are getting 3 disjoint interval. It means x is equal to 3 and x is equal to minus 3 divides the real number line. Here you see x is equal to 3 and x is equal to minus 2 divide the real number line, into 3 disjoint interval. Yes or no? 3 disjoint intervals. What interval? One interval is what? Minus infinitive, minus 2. Another interval what? Minus 2, 3. And what? 3 to infinitive. So 3 intervals. So we got the 3 intervals. Yes or no? First interval what? First interval is minus infinitive to minus 2. And second interval is minus 2, 3. Understand? And third interval is 3 infinitive. So you have to see in these 3 intervals, in which interval the function is strictly increasing, in which interval the function is strictly decreasing. Is it clear? Let's see, let's check. Understand? Okay. Now see, in the first interval, you see, so in the first interval you see, okay, case 1, when x belongs to minus infinitive to minus 2, it means the number can be, we can write minus 4 also. Suppose the number I will take minus 4. Let x is equal to minus 4. Let x is equal to minus 4. If x is equal to minus 4, you can put the value in the f dash x. You see, it will be 6 into x minus 3 and x plus 2. Understand? Okay. Yes or no? You will take x is equal to minus 4. Then you see, clearly you understand. You will putting these values here. X is equal to minus 4. So this value will be negative. And here also this value will be negative. Minus 4 plus 2 is minus 2 is negative. Minus 4 minus 3 is minus 7 is also negative. And the value will be what? Positive. Means greater than 0. That implies f dash x greater than 0. Hence, f is strictly increasing. Understand? Very simple question. Increasing in the interval minus infinitive minus 2. Right? Is it clear? The function is strictly increasing in the interval. So the function is strictly increasing. Understand? Second interval is minus 2 to 3. Let's see the second interval, case 2. Suppose when x belongs to what? Minus 2 to 3. Okay. In this interval, x minus 2 to 3 means we can take the values of x is here. X may be 1, x may be 2. Okay. Let's take any one of the point. Let x is equal to, suppose I will take 2. Understand? In this interval, and you see what is the value of f dash x. You see, if you putting the values and x is equal to 2, so 2 minus 3 it will be negative, and here 2 plus 2 will be positive, so it will be negative. It means less than 0. So x is f dash x less than 0, f dash x less than 0. Understand? So that implies f dash x is less than 0. Hence, f is, since the derivative of the function less than 0, it means the f is strictly what? Decreasing according to definition. Decreasing in the interval what? -2, 3. Is it clear? So function is strictly decreasing here. In this interval, function is strictly decreasing in this value, in this region, in the interval -2 to 3. Let's see the next interval, 3 to infinity. Last interval, third interval. Okay, in the case 3. Okay, understood? Case 3. So in the interval when the domain of the function lies between 3 infinitive, understand? Let x is equal to what? I can take x value more than 3, greater than 3. Let's see 5 or 6 or 6. Let x is equal to 6. If x is equal to 6, then you see f dash x, f dash is what? 6 whole into x minus 3 whole into x plus 2. Okay, and here x is equal to 3 means what? 6 minus 3, it will be positive value, and 6 plus 2 is 8, is also positive value. So here the resultant will be positive, plus into plus is plus. That implies f dash x is greater than 0. Thus f is strictly increasing in the interval 3 infinitive. Understand? Here the function is strictly increasing. Is it clear? Is it clear, all of you? Okay? Is it clear? So you saw here in which interval the function is strictly increasing. We got, here we got. So first bit, f is strictly increasing in the interval minus infinitive to -2 union 3 infinitive. In this interval, in this two interval, the function is strictly increasing. And again the bit, okay, the b bit we got, f is strictly decreasing. Understand? Everybody clear? How to find out the increasing and decreasing function? Very easy. So strictly decreasing in the interval, which interval? -2, 3. This is the required answer. Okay, we wanted to do. And is it clear, all of you? Is it clear? So very simple question, and also it is an application, important application of the derivative of the, using the concept of application of derivative, we can find out whether the function is increasing or decreasing, whether the function is strictly increasing and decreasing. Okay, thank you.